Good morning. I just want to go through fractions, proper, improper, equivalent, using these blocks. And then I'm going to let you guys play around with these blocks a little bit to try to problem solve yourselves. So this yellow block is a hexagon. It has 6 sides. And in the case of this, we're going to call the hexagon one whole. Okay, so the hexagon is a whole. Remember, a whole can be any shape. A whole can be a coffee cup. A whole can be one Miss Bowen. A whole can be one pair of glasses. One anything is a whole. And then a fraction is a part of a whole. So how many of these red shapes fit inside the hexagon? What fraction of the whole is the red shape? You may automatically know the answer to that, or you can check. You can actually place the shapes over the whole. So 2 red shapes fit in the whole. So 1 red shape is half of the whole. What about these blue shapes? How many blue shapes fit in the whole? Well, let's see. You can nicely put one like that. Might have to turn them a little bit. Takes a little bit of spatial thinking. There we go, and we need one more. So the blue shape is 1/3. Let's assume they fit. There we go. The blue shape, there are 3 that fit in the whole. So 1 blue shape is 1 out of 3. So far, so good, I would imagine. Okay, so the blue shape is 1/3. And I'm going to give you a link to this website so that you guys can actually do this yourself and show what I'm showing. So last but not least, the triangle. How many triangles fit in the whole? So again, you're going to have to turn them to fit them. What do you guys think? How many will fit? Oh, so how many triangles would fit in this red shape? Ah, that's a good question. Keep going. So 3 triangles makes half of the hexagon. And 6 triangles makes the whole hexagon. Okay, so you can see that 6 fit there. So what fraction is 1 triangle? 1 out of 6. So every fraction has equal parts, but the size of the parts is different. So you can see that 3 triangles is the same area as the red shape. So 1/2 is actually equivalent or equal to 3 out of 6, 3 triangles. So 1 red shape is the same as 3 triangles. Those 2 fractions, 1/2 and 3/6, are also called equivalent fractions. They have the same value. How many triangles would fit into this blue shape? What do you think? Oh, 2 seem to fit pretty nicely. So if 2 triangles, 2/6, because you're always relating them to the whole. So triangles that fit in the whole, 2 out of 6, is the same as 1/3. So again, those are equivalent fractions. Okay, I'm going to stop there, and you can just practice trying to figure out what other fractions you can make that are equivalent. So what are the equivalent fractions to 1 whole? I hope you played around quite a bit and figured out some of the equivalent fractions to a whole. We've talked about this before. So if I have two red shapes that fit in the whole, then, and I keep both red shapes, then an equivalent fraction to one, or a whole, is equal to 2 out of 2. A whole could also equal 3 of those blue shapes like we showed. So if you had all 3 blue shapes, all 3 blue shapes, you would have an equivalent fraction that is 3 out of 3. So all 3 blue shapes covering the whole is the same as, or 3 out of 3. Or if it was the triangles, 6 out of 6. 12 out of 12 would also work. Any number where the numerator and the denominator are the same will give you a whole. The key with fractions, again, is that the parts are equivalent. Okay, so what happens when we have numbers that are more than just 1? We've been working with these a little bit. So now we have 2 wholes and maybe a half. Let's write this differently. So I'm just going to move that over. Actually, I'm going to delete it because it's on a video. You can go back. Let's say we have 2 wholes and a half. Okay, we learned that there are 2 ways to write this. We learned that you could write this as 2 wholes and a half. So that is called a mixed number. Or that you could write it as fractions that are all red parts. So let's look at that. So it could be 2 and a half. So 1 whole, 2 whole, and a half. Or if you made it in red parts, how many red parts would make up 2 and a half? How many halves make up 2 and a half? And we need one more, obviously. So it's now you're thinking about all the wholes as the 2 out of 2 fractions. So you would have 2 out of 2 plus 2 out of 2. Those are your 2 wholes plus a half. So altogether you have 1, 2, 3, 4, 5 red pieces, 5 halves. So writing it this way is called an improper fraction. Oops. Okay, so let's try again. Let's write 1, and we're going to do 2/3. So 1 and 2/3. This should probably be turned and look like it's part of the whole. Oops. Okay, well, I'm not having any luck turning that just now, am I? There we go. Perfect. Okay, so 1 and 2/3. So you can write it as a mixed number, 1 and 2/3, or how many blue pieces would make up the whole? How many blue pieces would cover the yellow piece? So we have 1 and 2/3. This is your mixed number as a whole number and a proper fraction. Or you could write it as there's going to be 3 blue pieces that could make up the whole, plus the 2 blue pieces that are left. So 3/3 plus 2/3 is equal to 5/3. That is your improper fraction. So this is another thing I want us to play with, is creating mixed numbers, so numbers that are greater than 1. So you guys can, in a chart or on this type of screen, create a mixed number that is greater than 1. And then I want you to tell me that mixed number as an improper fraction. Okay, So understanding that you can either write it as the number of wholes and then the proper fraction, so 1 and 2/3, or how many thirds in total make up that 1 and 2/3. So there are 5/3 that make up that shape. And remembering that the denominator of the improper fraction is the number of parts in one whole. I really hope this helps. Okay, all the best, good luck, and I hope you have fun with these blocks.